Alright, page 3. Alright, page 3 of your review sheet. Alright, so it says tell what each of these transformations, what do they do? And again, this is chapter 6, and so you can either A, understand them, write them down on your 8.5 by 11 sheet, or what you want to do. Alright, so the big S is either size change or scale change. Now, when you only have a 2, that means that you have a size change. That means this 2 is going to affect your X and your Y. So that's called a size change of magnitude 2. Then when we have this one, when we have 2 comma 3, that means that this 2 affects your X and this 2 affects your Y. So that means that your X's will be multiplied by 2 and your Y's will be multiplied by 3. So this is called a scale change. And remember that one way you could write it out is maps just the point x, y onto 2x, 3y. Meaning that you're going to, whatever your x value is, you're going to multiply it by 2, and then whatever your y is, you're going to multiply that by 3 when you have a point. The little r, remember what the little r means? A reflection. So now this one means that we're going to reflect it over the x axis. So reflection over the x axis. Alright, so that means that if you're given a point, you're going to be reflecting, if you're given a point, you're going to be reflecting that point over the x axis. That's what reflection means. Right? Now, so what does this mean? This means that it's a reflection over the y-axis. So again, you have a point, and you're reflecting that point over the y-axis. This means that you're having a reflection over the y equals x. And that's a line, just so you guys make sure. So remember, so you have your, if you have y equals x is the line that's right there, right? And so if you had a point here to reflect it over here, it would be right there, right? So you're reflecting it over your y equals x line. The big R is a rotation of 90. Degrees, and so that means that you would take a point or a picture and you're rotating it 90 degrees, right? So you would start here and you're rotating it 90 degrees, right? So it'd be over here. So if you started there, you're rotating 90 degrees, right? So it's like you're starting here and then you turn your paper, rotating it 90 degrees. So it would be over into the second quadrant, or simply a rotation of your 90 would be right there. A rotation of 180. Again, a rotation of 180 degrees would be if you have a point and you rotated that point 90 and then another 90, that's 180 because you're rotating it, your picture 180, right? Because you have a 180 degree right there. And then this is a rotation of 270 degrees, right? So again, you're taking your point and you're rotating it. So if you rotate it, if I'm going to do it, the turning your paper away. So this is in your first quadrant, right? So originally it's in quadrant 1, right? So now we're going to turn it, your 90, that would be quadrant 2. 180 would have been quadrant 3. And then your 70 would be in quadrant 4. So that means your point is going to be now in quadrant 4. Right? So that means rotation of 270 is right there. And then the T is a translation. That means you move your point to the right, whatever this is. So if it's, since it's positive, you're moving it to the right 2, and then 3 up, because that's your X and that's your Y. So this is called a translation. And that's a translation of X, Y. And remember, it's moving that point, and you're moving your X value, you're going to add the 2, and then the Y value, you're going to add the 3. Right? I probably should have put that one there for you. Hopefully that doesn't confuse you. But whatever your Y value is, this is going to be a new number, right? And this is what your new X number is, right? And so that would, whatever your point is, so if your point on this one, I'll do a point. So if your point was 1, 1, then I would add, my new point now would be 1 plus 1, which is, or 1 plus 2, which is 3. So my new point would be, so if this one was 1, 1, my new point would be 1 plus 2, which is 3, and then 1 plus 3, which is 4. So my new point would be 3, 4. So 1, 2, 3, 1, 2, 3, 4. And that's where my new point would be. And that's what those mean. Alright. So now it says to give the above in matrices. Well, the first one was actually, I think I'm going to go over here and write down what they are so that we can talk about them. So this first one was S sub 2, and then B, which is S sub 2, 3, and then C, which is R of X, and then D was R of Y, reflection of Y, and then E was the reflection of Y equals X line, and then F was the rotation of 90, G is the rotation of 180, H is the rotation of 270, and I is T 2, 3. Alright, so now it says to give the matrix for each one of these, right? So remember that you always want to start with your identity matrix. And what is my identity matrix? So actually I'm going to add that over here. And we have the identity matrix. Your identity matrix, remember, is, where's my ones? Right, on my diagonal. So my ones are here, so I have 1, 1, and the other ones are zeros. So we're always going to look at the identity matrix when we're doing a lot of these. And remember that the top one is your X's and the bottom is your Y's. Alright, so your first one is, remember that this 2 affects my both my X's and Y's, so that's why you get 2's right there. So we have 2, 0, 0, 2 is that one. Then on S2 and 3, that means that this was your X, so that's your 2, and this one affects your Y, so that's a 3. So then I'm going to put zeros in the other spot. Now we have C, which is your reflection over the x-axis. So remember, when you are reflecting over the x-axis, what happens? And if you have a point here and I'm reflecting it, if I have a point here and I'm reflecting it over my x-axis, what happens to my x and y? My x's stay the same, but my y's go negative. So remember that this is my y value, so that means my x's stay the same and my y's go negative. Alright, so looking at this one, we have here, I can draw that, and we have here, again, you can understand them, how to get them, or put it on your 8.5 by 11 sheet of paper, whatever you choose to do. So now we have this one, and we are reflecting it over the y-axis. So what happens? We have here our y's stay the same, but our x's now, our x's go negative, right? So our x's are going negative, so that means we have negative 1, 0, and our y stayed the same, so it's 0, 1. When we reflect over the y equals x line, what happens is our x and y's switch places. So since our x and y switch places, these are going to switch. You're going to put your y's on the top, so that means it's going to be 0, 1 on the top, and on the bottom you're going to have 1, 0. Alright. F is the rotation of 90. Remember that the rotation of 90, the rotation of 180, and the rotation of 270 all come off of the unit circle, right? So the unit circle, remember you have your unit circle, so since it's a unit out, that means that this point right here is your, what point's that? 1, 0. And then this one is your 0, 1. And then over here is the next point right here is negative 1, 0. And then down here is your 0, negative 1. Alright, so remember when you do rotation of 90, you always go to the 90 spot. So this is your first one of your 90. Right, so rotation of 90 starts here. And then you take this point, so you take that one and you insert it into your matrix, so you have 0 and then 1. So that's your point. Because remember, we have a point goes up and down, so we have 0, 1. Then we go to our next one, so we grab the next set of numbers, which is negative 1, 0. So we had 0, 1, and then negative 1, 0. So your next one, we have rotation of 180. So rotation of 180 starts here. So our first point is your negative 1, 0. So I have negative 1, 0. And then I start there and I go to the next point, so it's 0, negative 1. So remember, rotation of 270 would start here and it would go to the next one, right? So the first one would be 0 and negative 1, so 0 and negative 1. And then you go and grab the next one, which is 1, 0. Alright, if you had the rotation of 360, remember that that also equals your identity, because we're back where we start from. That's why it's your identity, so it's back where you started from. And so that, if we had that, the rotation of 360 would be your identity, which would have been 1, 0, and 0, 1. Alright. Letter I. Letter I said that we have the translation, the translation of 2, 3. So remember that when you add matrices, you can either whatever how many points you have is how many it will be. So say we had 2 points, it would be 2, 2, and then on the bottom, because that's your x's, your 3, 3 would be your y's. Now if you had a third point, it would be 2 and 3, because when you add matrices, remember you need the same amount. If you wanted to, you can also remember that it is x plus 2 and then y plus 3. Alright. Now I took up probably a little bit more room than I should have. This I is right down here, so I probably should circle that. Number 9 and 10, if you have a graphing calculator, I know you can just simply plug it in. So I'm going to show on the graphing calculator how to do that. And then if you don't have a graphing calculator, then you can stay with me, and then we're going to do them out the long way. So on a graphing calculator, if you have a graphing calculator, you would simply turn your graphing calculator on. I'm going to move this all over so that we can see my calculator too. That light glare, it kind of hard to see sometimes, huh? Alright, so I'm going to go and actually go to my my matrices. So I'm going to input this into my matrix. So it's your let me see so you can see those keys too. So we're going to go second in matrix, because see how matrix is down there? So you go second matrix, and I'm going to go to edit first, go to edit, and I have a 2 by 2. So I'm going to edit my first one, and if you didn't have any in it, you'd simply put a 2 by 2, and then now we can enter the points. See how this one right here is highlighted, that first one? So that's my 2, and then you push enter, and then it goes to the next point. So then you go 3. The next number we have is your -5, so I'm going to put -5, push enter, and then 9. Now make sure you push enter, because right now if you notice on mine it says a 9 down here, but a 15 is up there. So if you don't push enter, you're gonna possibly get it wrong. So you really want to make sure you check it, or move your cursor around and make sure that they're the right numbers. Alright, once we have the right numbers, then we're going to go to second quit, and we're at the front screen. So now I want to pull up this matrix. So I go second matrix, and it was matrix A. So I'm going to go matrix A, so I can hit a 1 if I want to, get matrix A. And now it says to find the inverse of it. Well, your inverse key is right there. It says x to the -1. That's your inverse key. So you're going to hit that one, and I'm going to push enter. See how it's all decimals? Well, I want it to be fractions. So I'm going to go math fractions, which is 1, and then push enter. And this reduces it too. So that means that my answer is 311, and then 533, -1/11, and 2 and 33. So that's your answer of your inverse. Now, you can also, when you're doing this, if you go second entry, it pulls up your last one. That's the one before. When we had our A inverse, I could have put math fraction right there, and that would have done it right away. It would have given me a fraction right away. Alright, now let's do this one. So we have here, we're going to multiply these matrices. I do not believe that it tells you on your midterm that it's a 2 by 3 or a 3 by 2, but remember, what drink are we drinking? RC Cola. So since we're drinking RC Cola, remember it's your rows by columns, and that's also how you multiply. But so rows by columns. So I'm going to go to your matrix so I can put these. So I'm going to go second matrix, and I'm going to go to edit, and I always edit number 1 first. So I'm going to edit number 1, and it's a 2 by 3. So I'm going to go 2 by 3. Now if you thought it was a 3 by 2, say you put a 3 by 2, see how it doesn't look the same? We know we did it wrong. So then you would just push your up arrow to redo that. So I'm going to go 2 by 3, and I'm moving everyone by hitting the enter button. So I hit enter, and then I'm inputting what I have. I have a 2, I have a 3, I have a 1. So I'm pushing enter each time. 4, enter, 6, enter, -1, enter. That's right. So now I look again to make sure I have the right numbers, and then I go and I'm going to enter my second matrix. So I'm going to go second matrix, and I'm going to go to edit. But now since this is A, since I'm calling this A, I'm going to call this B. Right? So I'm going to edit, and now I'm going to edit B, so I'm going to hit number 2. And this is a 3 by 2. And again, if you see how you can look at it, so when we know a 2 by there, if I put a 3, yep, it's going to be right. So look at that, 3 by 2. So you look to see it, make sure you're doing it right. Then this is your first number, so 1. Watching where your cursor goes, right? Each time watching where your cursor goes. 5, -2, 0, 1, 8. Now, re-looking to make sure everything's in right. Now, how do I get back to that other screen? Do you remember? Second quit. Did you tell me second quit? Hopefully you did. Then I'm going to clear off this screen so we can see what I'm typing. So I'm going to say matrix A times matrix B. So how can I do matrix A? So I go second matrix, and I'm going to go A, which is 1, and then second matrix B, so that's 2, and then simply go enter. So my answer is -3, -9, 18, and 12. Right? Alright, so that is page 3 if you have a graphing calculator. If you do not have a graphing calculator, I am going to work through those two problems out so that you can, so that if you don't have the graphing calculator, you can still do those problems. It takes a little bit longer, so I figured I'd do the graphing calculator first. Those of you that need to, stay with me. Alright. So I'm going to now flip this paper over because I need to do the inverse of these. So I'm going to flip this paper over, and now it says to, it said over on the other side, it said to find the inverse. So number 9 said to find the inverse of the matrix 2, -5, 3, 9. Right? So the first thing we need to do is we need to have the formula for that. And remember, the formula starts with saying that the matrix is A, B, C, D. And you need to know this part of it so that you can know where the numbers are coming from. And the second thing it says to do, so the first thing is we need to know that. The second thing we need to know is the determinant. And later on it's going to be abbreviated DET. Alright? The determinant is where you take your AD, so it's these two, multiply them together, and you subtract your BC. Alright? So it's going to be AD minus BC. And then the third thing, and I'm going to move my thing over so that when I'm writing, you're going to see everything. There you go. The third thing we have, I'm going to move it over just a little bit more. Alright. There. Now if I write to the edge, you can see it. So the third thing is we need D, A and D switch places. So D is up here, and A is going to be down here. And then, remember, it's going to be over the determinant. Each one's going to be over the determinant. And then these two, they just go negative. So it's negative B over the determinant, and then negative C over the determinant. And then you'd have to put your brackets around your matrix. Alright, so now what does that mean? So now that we have the formulas, we can now use them. So now this is our first one, knowing that this is A, D, B, C, we're good. So now we find the determinant. So we're going to find DET. We're going to find DET. Remember, it's multiply this together. So we have 2 times 9. And then we're going to subtract negative 5 times my 3. So we have 2 times 9, which gives me 18, minus negative 5 times 3, which is negative 15, so I have a negative 15. So I have negative is positive, so I have 18 plus 15. 18 plus 15 is 33. Right? So my determinant is 33. So now it says to switch these two things. So I'm going to go 9 is going to be at the top, and 2 is going to be at the bottom. And then these go opposite. When they say negative, that means opposite. So this is a negative 3. Hear that? My coffee is shutting off. It's been an hour since I've been doing this. Actually over an hour, because I didn't even start my coffee until after I started the first one. So anyways, so negative 3, and this is 5. And we have all over your determinant, which is 33. So that's your first one. Now I have to reduce it. What goes into 9 that goes into 33 is 3. So we have 9 goes into that 3 times, and then 3 goes into 33, 11. And then 3 goes into this one also, so it's negative 1 over 11. Nothing goes into that, so it's 5 over 33. And then, oops, should be 33, so we have 2 over 33. Alright, so that is number 9, done out without the graphing calculator. Number 10, the last one of this page, without a graphing calculator. Number 10 said to multiply, and I'm going to read them downward, 2, 4, 3, 6, 1, negative 1. And we have here 1, negative 2, 1, 5, 0, 8. So remember, what drink are we drinking? RC Cola. So rows by columns. So rows by columns. So that means you have to go 2 times 1, and so I don't have to write everything out. What I'm going to do is actually, I'm going to put my calculator right here. So I'm going to turn on my calculator. I'm going to clear it so you can see what I'm doing. So I'm going to go 2 times 1 plus 3 times my negative 2 plus 1 times 1. Now if you don't have a calculator that you can throw this in that doesn't know the order of operations, then what I would do is I would do it out this way. So I have negative 3 as my first number. So if I didn't have a calculator that I could do this with, what I would do is go 2 times 1 and do it in my head. 2 times 1, you guys know this, is 2, plus 3 times your negative 2 is 6, negative 6, plus 1 times 1, which is 1, which gives me negative 3. So then we take this, so this one is the first number. The second number is determined by this and here. So again, I have 2 times 5, and the reason why I'm putting it out so you can see 2 times 5 is so if you wanted to write it out, you can. 2 times 5 plus 3 times 0 plus 1 times 8. And that gives me 18. Then the bottom number, the bottom one, let me see if I can grab real quick, grab my different color, help you out for a sec. Can you see this color? I don't know, can you see red? Oh yeah, you can see red. Alright, so the bottom one, that's where it gives you the bottom one. So this will be the first number, that'll be the second number of the bottom. So then you go 4 times 1 plus 6 times the -2 plus -1 times 1. Gives me a -9. And then my last number, I'm going to clear that again. I get 4 times 5 plus 6 times 0 plus -1 times 8 is 12. Alright, well, I don't know. I wonder if this finishes. I don't even know if it doesn't. But anyways, that's the end of my page 3. If you are still with me, you're going to get kind of a bonus. I'm going to, let's see if, I don't even know if this will work, but I'm going to see if you can see out my window. See what I can see. Kind of weird. Maybe not. Where would that be? There's my hat. Oh, there's my window. There's my window. My house is all log cabin. It's like, I don't know if you can really see it right there, but that's the light fixtures. And then anyways, that's my window. And so when you're seeing out my window, when I'm looking out my window, I can see the trees, and I have a lot of woods. I actually live in Lansing, but you can see all my, you can see I live downtown Lansing, or not really downtown, but on the outskirts of Lansing, but in the city limits. And in my neighborhood, we're the only ones that have so many trees out the window. But I grew up on a farm, so I love my neighborhood, or my yard, because it has so many trees, and it reminds me of when I grew up. So that's a little bonus if you were still watching. Alright, enjoy, have a good day, and I will put up page 4 probably, let's see, I don't even know if you're still with me, probably maybe in an hour or so, because I'm going to take a break and I'm going to go eat. Alright, talk to you guys later. Enjoy.